kilograms in other parts of the class. This is called atomic mass units. So two atomic mass units, or 2 units from the protons, 2 from the neutrons. How much mass do the electrons really add to this atom? According to our chart, the numbers that we're going to use. Each one has a mass of 0. So how much are they adding in all? 2 times 0 is 0. Now, it doesn't mean that they don't have any mass, but the mass is so incredibly small compared to the mass of the protons and the neutrons that we can leave it out when we're working with atomic masses. As long as we're consistently leaving it out with all of the atoms that we're going to work with, then it'll be fine. So our total mass here is 4. So when we work with relative mass and relative charge, it makes it a lot easier instead of us having to memorize those numbers. And like we said, we've worked with those. Have we talked about charge? If we said we had something with 3 protons, we've talked about how many electrons we would need to balance it out. Because each proton has the same charge as each electron does. So as we look at the structure of atoms, we are really easily into starting to understand a little bit about the periodic table. One of the things you've already noticed, and quite a few of you have commented on some of these, and even when we looked at the whiteboard, some of the comments kind of led to this idea that the elements are arranged in order of increasing proton number. So when you go from one element to another, from left to right, each element has an increasing proton number. We talked today about how the columns are called groups and the rows are called periods. So if we want to find a particular, if I wanted to ask you to find a particular element on the periodic table, I could refer to the group number or the period number. But even more than that, if we know the group number, it tells us something about the atom. Or if we know the period number, it tells us something about the atom. So what does the group number tell us about the atom? Ashley?
How many electrons it has in the shell.
Okay. And what does the period number tell us?
How many shells?
How many shells? How many of the outer energy shells? So the group number tells us the number of electrons in the outer shell. So look at lithium on the periodic table. How many electrons would you expect it to have in the outer shell?
3. No.
In the outer shell.
1.
Not the total number of electrons, but just the outer shell is 1. And why do we know that it would have 1? What group number is it in? In group 1, right? How about potassium?
It would have 1.
It would also have 1 because it's in the same group as lithium. It's also in group 1. When we talk about, when we do talk about the when we talk about the number of electrons in the outer shell, we really are, in our class, we're really going to focus a lot on the first 20 elements, especially when it comes to that structure of protons and electrons. And that's why when I quizzed you about the names and symbols of the elements, we really only focused on the first 20. Something happens that's a little different here in the middle. And we'll talk about it a little bit when we talk about bonding, but we won't focus a lot on it. But if you take a full year of chemistry, you will focus more on it. But what happens here is we keep adding electrons. Calcium has 20 protons, so if it's neutral, it would have 20 electrons. Okay, but if we move down here to iron, which is Fe, kind of here in the middle, it has 26 protons. How many electrons would iron have if it was neutral? It has 26 protons. How many electrons if it was neutral?
26.
26. But something kind of different happens. Anytime that we're working with these elements in the middle, instead of those electrons getting added to that outer shell that has the highest amount of energy, they get added to these other shells that are lower energy. So they kind of get hidden in there. Because of that, I really didn't want you to try to draw the structures of some of the bigger ones. That's why some of you noticed you had an X on a couple of boxes on your worksheet.
Yeah.
When you try to draw the structures here based on what we understand of drawing structures, you're going to get really caught in kind of a circle of not getting to seeing the part of the structure that we want to see. Okay, so we won't focus a lot on this, but it's important to kind of recognize that not only is the periodic table a little bit differently shaped here, there is something different happening in this area as well as the elements that are down at the bottom. Okay, find bromine on your periodic table. Looking at that, tell me how many shells of electrons would we expect to see, and what would the number of electrons be in the outer shell? 55 is its nucleon number, its mass number? Sorry, 35? Okay. 4 shells. Why 4 shells, Fernanda? Because it's in period 4.
Oh, it's right here.
How many electrons are going to be in that 4th shell? Anthony, what do you think?
What?
How many electrons are going to be in that last shell for bromine? 7. Why? That's what somebody told you. Why do you think they said that?
Because
What's significant about 7 electrons? What number tells us if there's 7 electrons there? The group number or the period number? The group number. So when you bring that periodic table with you tomorrow, you're going to be able to find that, right? You lost it. I think that's going around. It's catching or something. Okay, find radium. Try the same thing. How many shells? Radium. Find radium. How many shells and what number of electrons in that outer shell?
oh, right here. No. Is this?
Luis?
There's 7 shells and 2 electrons on the outside.
Good. 7 shells, 2 electrons on that last shell.
Oh, okay.
Because it's in, what period number is it in?
7.
Period number 7. And what is the group number?
2.
Okay, but we also noticed that there's something different about group 0. What did we notice that's different about group 0? Its shells are full. There's a couple of words that we use when we're talking about its shells being full. And these are words that we will start using, but just like some of the things like proton number, atomic number, we'll make sure that we understand them, right? So valency is a term you're going to see quite a bit. And it's one of the definitions of it, one of the better definitions, is it's the combining power of an atom or group of atoms. Go ahead and write that down, but really the second term is the one we're going to focus on in this unit, and when we get to talking about bonding is when we'll really talk a lot more about this idea of valence. But the second idea says valence electrons, and that's an easier one to start with, an easier one to understand also, because it's the number of electrons in the outer shell of an atom. So, and I know I heard at least one group talk about that, because sometimes when you, if you were, took a physical science class last year, maybe when you were in 7th or 8th grade, when we were talking some about atomic structure, this term of valence electrons is one that comes up quite a bit.